Values, something that I struggle with understanding and applying just because it wasn't explained to me in a way that it could be actually applied to something in real life. Um, I can do a calculation. I'm pretty sure everybody can plug in numbers, but to actually use it and utilize it in your company or for someone else, if you're working for them, is an entirely different thing. So, the first thing we're going to start with is our data. And these versions, this would actually is like email campaign A and then email campaign B. A is control, quote unquote. That means our standard. And then variation is B. That means we're doing something different. It can be the copy, it can be an offer, something that's different. Visitors is how many people that actually visit from our um, campaign. And then our conversions, that means people that actually converted. So 350 for this one and 300, we can kind of see with our mind's eye that there's an increase, of course. To do the conversion rate, we just multiply it by the visitors. Okay. So I want to talk a little bit about what they call a null hypothesis and how this connects to the standard error. So the null hypothesis is basically that whatever you're doing is not significant. That's how I think of it. Like it's not significant, or you think that I think someone says I think that there's not going to be a big variation. It's going to stay around the same averages, and we should do something else, right? So our whole thing of a p value is to say that no, this campaign is above average. It's statistically significant, not above average, but statistically significant, and we should invest more into these types of campaigns. Okay. So null hypothesis goes against it, and the hypothesis or what you're wanting to push is the opposite, right? So this formula breakdown is basically under assumption that the null hypothesis, which is quote unquote H0, is true, right? That's the standard calculation error. Then we calculate the z value, which is this one. And I'm going to make this a little larger so you can see. And the z statistical measure how many standard errors observed difference away from the expected difference, right? So a difference, the spread away from the expected, I call it averages, but the expected zero under H0, which is the null value, okay? And we calculate this by, and I like to think of B and A as events, but you can think of it as yourself, but observed differences. It's the actual differences of these events. And these are the conversion rates. So we use the conversion rates as the differences. So we're going to subtract our version from the control. And we get 0.5. And that is significant, but let's just say we didn't know it. If we did know it, we would actually go and we would look it up on a Z chart or Z table, which looks like this. Or you can just do a calculation. Let me go back. A calculation like this one, where the area under the left side is Z is approximate this number. So the one tail, if it's two tail or one tail, so if one tail is going to be a 1 minus this, which will give you this number here. And if it's two tail, which is the A-B testing, that's what we're doing, A-B testing, is going to be 2 times this number here, which is 0.0230, which makes it 0.46, and we can round that up to 5, right? So visuals are so important to me. This is like, again, probability has to do literally with the planetary motions. So being visual helps a lot. So the first thing I'm going to do, and I switch some stuff over. It doesn't look like it's going to let me. There we go. So this is the Z score that we got, right? So this is represented by, and I'm going to make this larger. Oopsie. Represented by, we look in here, we say calculate Z-score 1.994, okay? So that Z-score is going to lie here. That's the straight red line. Then we have the critical value, which is 0.5. That means that it's significantly statistically significant, and that lies within the green, which is right here. Okay. And because the p-value lies within there, which is under here, which is shaded red, that means that it is significant. It is statistically significant. Okay. So that H0, not rejected, lies under here. So this is the 0 under H0. Okay. The Z statistic measures how many standard errors the observed differences of PB from BA, which is our conversion rate, from the expected difference. Okay, so it does not lie under this area, so that means that we can reject it. That is the best way I can think of it. This is a model. That means that not the whole details of the origin and how this is created and why was it created and how everything works integrally is not provided to the public, at least in non-Ivy League schools. I don't know. I mean, if you guys know, please help send some information. I don't know the ins and out, but I do know this is how it's calculated and this is how it's visually plotted. And this is how I would use it, right? So the conversion rates are used to calculate this, and you can see that, yes, according to the campaign, we actually have enough of a change from the control to say that this is significant. Now, how would I use this? So in a situation, and I think I mentioned this in the other video, where someone wants to interrupt my campaign. Let's say that I need a full 6 months campaign and I only have 3 months in, they want to basically scrap my campaign idea and everything else. I could run a p-value and say, technically, this is out of the range of the average. Like, we're actually getting sales that is above average. It is statistically significant. And, you know, they can look at the data information. Either way, it's going to go to my favor, because if it fails, the opposite fails. You know, they run a campaign and maybe just averages out to norm. But if they see it, hey, this campaign was actually doing quite well, and somehow it got interrupted and stopped. Okay. This is how I would use it in real life. Another way, which is the video that I recommend everyone to look at, where he breaks down multivariable model for performance when it comes to marketing, is you can use this as a qualifier. Let's say that I ran 12 campaigns, and out of the 12 campaigns, it had a p-value where it was significantly different in a good way. So statistically significant. I would then focus on those 6 campaigns and then focus on what made it perform so well versus the average. Like, what did we do? And then I can sort of focus on that and experiment with that. So I can use it to save a campaign, and I can use it to qualify what data I want to focus on building my next steps on my campaign or doing a review. So I hope that makes sense. If you guys have any questions about p-value, let me know. Until then, I'll see you next time. Bye.